Good morning, boys. So today this is your to-do list today, the one I just pressed on. It's still in the lesson Introduction to Energy. Yesterday you took potential and kinetic energy. Today you're going to learn about these 9 kinds of energies that you saw at the end of the video. We're going to learn about each one of them. So what you're going to do today is first you're going to watch video 1, which is right here. I'm pressing on it. Then you're going to watch video 2. You're watching it right now. This is the explanation that I'm giving to you. Then you're going to do worksheet 2, and these are the slides for today in case you need them. Okay, so let's go into the slides. Okay, so we have 9 forms of energy. First one is gravitational potential energy. It comes from the word gravity. Okay, as you can see here, gravitational. You can see this lady over here. She's holding the ball, but she's not letting it go. That means the ball has a potential to fall. So if the lady lets the ball go, okay, or she stops holding it, the ball will fall. Why? Because the ball has energy that comes from gravity. It's called gravitational potential energy. And it is potential because it's not moving. It's not moving yet. She's holding the ball. When she lets it go, it moves, it becomes kinetic. But right now, it's just gravitational, as you can see. So this is gravitational potential energy. Now, gravitational potential energy relies on the mass. So if the object is heavier, if we have a bigger ball, it will have more gravitational potential energy. And the height. So if she's throwing it from here, or if she's throwing the ball from here, where do you think it will have more potential energy? If she's holding the ball here or here? Position 1, position 2. Where do you think it will have more gravitational potential energy? Correct, at position 1. Because position 1 is higher, position 2 is not as high as position 1. So, gravitational potential energy depends on mass and on height. These two things. Okay, and the strength and the ground strength of gravity. Okay. Second kind of energy is called mechanical energy. It describes the ability to move or do work on objects. Okay? Look at this man, for example. He's holding a hammer and he is using the energy to pull the hammer inside. This is called mechanical energy being done. Okay? Mechanical energy of an object is the sum of the object's kinetic and potential energy. So kinetic energy plus potential energy together make mechanical energy. Look at this, for example. Potential energy, he's holding the spring and then he lets it go. Kinetic. Together, we say that he did mechanical energy. Okay? If you see a crane holding some rocks, if you see somebody moving a pulley around in the supermarket, this is all kinds of mechanical energy. Okay, now this is called elastic. This here is called elastic potential energy, but we're going to get to that later. Okay, next we have thermal energy. Thermal energy is the total kinetic energy of particles that make up an object. Okay, now this is kind of confusing when you look at this description, but what you need to know in general is that thermal energy is heat energy. Heat, al-harara, heat. Particles move faster at higher temperatures and lower at lower temperatures. Okay, I'm going to explain this. So you see, this is a heat source. Okay, it's on the stove. This is water boiling on the stove that's giving it heat. This heat is called thermal energy. Now, if you notice here, you see these particles? They are not moving as fast as these. You see these particles? They're moving really fast. So this here has more thermal energy. This has less. Why? Because here the particle movement is slow and here it's fast. So that's why particles move faster at a higher temperature. This has a higher temperature, the particles are moving faster. Lower temperature, the particles are moving slower. The faster the particles, the more thermal energy. So which one has more? 1 or 2? You're right. 2 has more thermal energy because the particles are moving faster. Why? Because we have more heat. So thermal energy, if you want to understand what it is, you can just say that it is heat energy. This is the summarized definition. Now think about it. Think about it. Which has more thermal energy, a bathtub full of water at 25 degrees or one at 45 degrees? You guessed it, 45 degrees. Why? Because 45 degrees is hotter. So the hotter things are, the more the more thermal energy they have, that means the more heat they have. Okay, and thermal energy is the total kinetic energy of particles. These are particles. The more they move, the faster they move, that means the more kinetic energy they have. This is the explanation of this this meaning that comes at the beginning. Okay. Next we have electromagnetic energy. Electromagnetic energy comes from the energy of electromagnetic waves. Okay, this is the electromagnetic waves. We call this the electromagnetic spectrum. Okay, it's waves of light. You as a human being can only see visible light. You can only see this right here, the visible light. You can see that part. Okay, you cannot see microwaves here. You cannot see radio waves. You can feel microwaves because you put food in the microwave, it becomes out hot. Okay, but you cannot see them. Infrared for heating, ultraviolet, X-rays that help doctors, gamma rays, they help kill cancer cells. So these are all kinds of rays and that are certain wavelength of the electromagnetic spectrum. Now all you need to know is that it's electromagnetic energy is the kinetic energy of electromagnetic waves. Okay, it includes visible light, X-rays, microwaves, okay, and all the other ones. All right, I'm not gonna give you anything that is confusing relating to this. You just need to know in general what it's about. Sound energy comes from the word sound. It's caused by vibration. Okay, now you don't see like this is a speaker and this is somebody's ear. Now you don't see, but this is how sound travels. It moves particles. Okay, you don't see the particles moving, but you can hear the sound. Now the sound can move through walls, and it can move through water, it can move through air, it can move through anything basically. That's why, for example, if you are in a certain room, you can hear people in another room because the sound moves through the wall. Why? Because the particles can vibrate through any kind of matter. So here they ask you, think about it. Why is it possible to hear sound through a solid wall? Because the particles vibrate through the wall. Okay? So this is basically sound energy. Anything that you hear comes from sound energy. All right, this is the next one, electrical energy. Anything that you use from appliance, your phone, light bulbs, light that you see, they all come from electric energy. Now, electric energy, look at this battery right here. Now, I know the battery has chemical energy in it, but it's converted into electrical energy. Okay, these are electrons moving. When electrons move, they go from the battery, they make the light bulb. So kinetic energy of moving electric charges. This E right here is called an electric charge. When electric charge moves through any wire, it causes electricity. Okay? It causes electrical energy. Also, you have lightning and static electricity. They're also caused by electric energy. This is lightning. Static electricity is, sometimes when you touch something and then you feel like you got electrocuted. When you sometimes you touch your friend and you feel you got a little shock. You touch a doorknob, you got a little shock. This is called static electricity. It's also kind of an electrical energy. This is an electrical outlet, also electric energy. This is lightning, also kind of electric energy. This one is called elastic energy. You see, this is a spring, okay? It is kind of elastic. Now, when he stretched the spring, there's potential energy here, and it is elastic potential energy. When he stretched this right here, you got elastic potential energy as well. And this energy is able to push the rock outside. Okay, you can observe this energy when you stretch a rubber band or squeeze a spring. This is a spring. This is like a rubber band. Okay, so this is elastic energy. Next, we have chemical energy. Now, chemical energy can come in a lot of forms. It can come as chemicals. You see, in a lab, you can mix two chemicals. You can have an explosion. You can have smoke coming out. You can have heat being produced. This is called chemical energy. There, in the battery, for example, you also have chemical energy inside there. You have chemical energy in here, matches, okay, fireworks. It's thermal, but also chemical. You have chemical energy in food. You eat the food becomes energy for you, and this energy is called chemical energy. Okay, the battery, it does give out electric, but it's chemical inside of it, and then when it goes out and, for example, it lights a bulb, it becomes electric. But inside the battery, what kind of energy we have inside the battery is called chemical energy. It comes from the word chemistry. So to summarize, chemical energy can come in the form of chemicals, batteries, fuel for cars, for example, food, matches, all these kinds. Nuclear energy is the potential energy stored in a nucleus of an atom. Now, you don't have to know much details about that, but you can know that it's just the nucleus of the atom has energy stored inside of it. Okay, for example, the energy given off by the sun is nuclear. Okay, this is a nuclear bomb. It happened because of nuclear energy. Now, nuclear bombs are very, very dangerous, very, very big, and nuclear energy is a really dangerous thing. These are atoms. The energy inside them is called nuclear energy. The last thing you need to know is that more than one form of energy can exist at the same time. Just like we said, the battery is chemical energy, but it can later be transformed into electrical energy. Lightning, for example, is electric and electromagnetic energy. The TV, for example, in your house, the TV has electromagnetic energy and electrical energy. Thunder is sound energy. Blowing wind has sound energy and mechanical energy because the wind is moving. It makes a sound and it also makes mechanical energy. Falling rain has sound energy and mechanical energy. So you can have more than one type of energy in things. They come together. Now, that's basically the whole thing you need to learn today. It's just the kinds of energy. This is the lesson glossary if you need to get back to it. Now, don't forget to do your Nearpod quiz and your worksheet. Good luck.